Hello and welcome to Startup Hack. Today we are going to talk about Task.WaitAll versus Task.WhenAll advanced concepts in C#. So let's jump right in. Make sure to check out the link down below because we always provide the code samples that you can pull down and follow along so you can see in our project. Now that you have a good understanding of basic usage of Task.WaitAll and Task.WhenAll, let's dive into some advanced concepts related to exception handling, cancellation, and performance consideration when working with multiple tasks in C#. So first is exception handling. When working with multiple tasks, it's crucial to handle exceptions properly. Task.WaitAll and Task.WhenAll provide different ways to handle exceptions. Task.WaitAll, if any of the task thrown an unhandled exception, Task.WaitAll rethrows the exception and calling the thread. You can use the aggregateException.Flatten method to handle multiple exceptions from multiple tasks. Task.WhenAll returns a task that represents the completion of all specific tasks. So if any of the tasks thrown in an exception, the task returned by Task.WhenAll will be faulted, and you can use the .exception property to retrieve the exception information. So here's an example. Now moving towards cancellation. Both Task.WaitAll and Task.WhenAll have overloads that accept a cancellation token parameter, allowing you to cancel the waiting operation. So here's an example of both WaitAll and WhenAll. Do you want to earn $100,000 a year? Do you want to become a software developer within just 3 months? With our amazing course and awesome tutors, you never have to worry about getting stuck. We help students to learn skills that companies want to hire. We are Startup Hack. Don't forget to subscribe our channel. So let's get started. Okay, now performance considerations. When working with a large number of tasks, it's essential to consider the impact on performance and memory usage. Here are some best practices. Use the appropriate method. Task.WhenAll is generally preferred over Task.WaitAll as it provides better performance and more flexibility. Avoid creating too many tasks. Creating a large number of tasks can consume significant memory and resources, so use task grouping techniques such as Task.WhenAll and Task.WhenAny to manage tasks efficiently. Consider using parallel link queue for operations that can be parallelized easily, such as querying a database or performing a calculation on a collection. Consider using PLN link queue. It provides a convenient and efficient way to parallelize operations and manage the completion of tasks. So here's an example. Avoid blocking whenever possible. Avoid blocking the calling thread by using asynchronous programming techniques. Instead of waiting for tasks to complete, use callbacks or the async or wait pattern to handle the completion of tasks asynchronously. So here's an example. After that, use task group. When working with a large number of tasks, consider using task groups to manage tasks efficiently. A task group is a collection of tasks that can be waited upon or cancelled as a group. So here's an example. Now moving towards error handling and best practices. In addition to exception handling, it's essential to consider other aspects of error handling and best practices when working with multiple tasks. So the first thing is error handling in task group. When using task groups, you can handle exceptions using the handle exception method, which aggregates all exceptions from the task in the group. So here's an example. Now moving towards performance best practices, minimize task creation. Creating a large number of tasks can consume significant memory and resources. Reuse tasks or use task grouping techniques to minimize task creation. Configure the thread pool. Adjust the maximum number of threads in the thread pool based on the workload and available system resources. This can help prevent resource exhaustion and optimize task scheduling. Use task scheduling APIs. Consider using the advanced task scheduling APIs provided by the system.threading.task.taskscheduler class to optimize task scheduling based on the workload. Here's a continuation of the in-depth Task.WaitAll and Task.WhenAll in C# and .NET Core. So here's a solution. Make block code async to. Like WaitAll, WhenAll aggregates exception from child tasks. So here's example. So remember to catch them. You can also handle exception on each task separately by using continuations. Continuations let you run follow-up logic when tasks finish. So here's example. This keeps the async flow while handling errors individually. So Task.WhenAll enables non-blocking coordination. Avoid blocking calls after await WhenAll. Handle aggregate exception from tasks. Use continuations for follow-up logic. And you are a master of async multitasking. Okay, now cancellation. Long-running tasks can be cancelled to abort them early. But how does cancellation work with WaitAll and WhenAll? So let's compare cancelling Task.WaitAll and cancelling Task.WhenAll. So Task.WaitAll cancelling with Task.WaitAll canceling, the parent cancellation token source cancel all child tasks. So here's example, easy propagation of cancellation. However, when all does not propagate cancellation to child task automatically, we must manually pass cancellation tokens. So here's example. So remember this key difference, it catches some beginners off guard. So in summary, wait all auto propagates cancellation when all requires manual token passing. Remember this behavioral difference. So thank you for watching this video. I hope you learned the advanced concepts of task.waitall versus task.whenAll in C#. So don't forget to subscribe our channel and hit the bell icon for latest updates. To joining our course, you can simply go to our website called startuphack.com. Thank you.